Sí.
Sí. Ah, espérame. ¿Hay alguien preguntando? Yo no sé si le pregunto a Eduardo si anda bien.
Sí, sí.
¿Cómo sabemos?
14 participantes arriba. 16, 18.
Sí, sí.
La gente puede elegir lo que quiere ver. Ah, nosotros no.
Sí, pero si lo dejan listo, sticker y cambio los apellidos. Nadie habla de la decano de la Ciencia de Datos.
Hi, Gil. I'm Liliana Porzani.
Hello, hello everyone. Yes.
Hi.
Hi.
Good.
Welcome. Thank you for being here today.
My pleasure. Yes, thank you.
We're waiting for a couple of minutes so more people can connect and then we start.
That's good.
Sí, si funcionaba el libro. Pero me extraña porque Eduardo iba a entrar. Ay, no.
Entró, pero acá no. Bueno. Estos tipos de televisión.
29.
Cero uno. Te dan 20 segundos. Exacto. El libro.
No sé si por eso se queda que cuando...
Bueno, ¿arranco yo?
Sí.
¿Cómo les va a todos? Mi nombre es Adrián Bonibardi, soy el decano de la Facultad de Ingeniería Química, para aquellos que no me conocen, los de acá creo que casi todos me conocen, o algunos por lo menos. Bueno, y en primer lugar agradecerle al profesor Strang por haber permitido hacer la traducción de este libro al español, y también la presencia de Eduardo Sáenz de Cabezón, que es un divulgador muy conocido de España, que está aquí, que va a decir algunas palabras también al respecto. Y bueno, básicamente comentarles que este libro, que tiene un nombre, si nos quedamos con la primera parte, con álgebra lineal, podríamos decir que es un libro de álgebra lineal, pero bueno, lleva algo más atrás, que es Learning from Data, o acá fue traducido como álgebra lineal para Ciencia de Datos. Está relacionado con el lanzamiento de una carrera de Ciencia de Datos que venimos trabajando ya de hace ya no sé cuánto, Liliana, pero 2 o 3 años seguro. 2 o 3 años, una idea que empezó a trabajarse de una manera bastante ambiciosa, tratando de llegar a hacer un programa conjunto con otros lugares. Finalmente dijimos, pongamos las cosas en orden en casa, veamos qué es lo que tenemos nosotros y qué es lo que podemos realizar. Se larga esta carrera, el proyecto se aprueba, y a partir del año que viene tenemos licenciatura en Ciencia de Datos en Santa Fe. Básicamente eso, y el libro, bueno, obviamente es una de las partes a las que hace referencia esta carrera, o hace referencia a la carrera. Así que bueno, con lo mío es sumamente breve, es agradecerle a todos los presentes, y por supuesto agradecerle el trabajo que han hecho Cecilia Morín, Liliana Forzani y Pedro Morín en la traducción, que sabemos que no es fácil, que tienen que actuar expertos no solo en la disciplina, sino también en algunos detalles de la lengua, que son importantes, y ahí Cecilia creo que ha aportado mucho. Así que bueno, gracias a todos por estar acá y por ser partícipe de esta presentación.
Well, I'm Liliana Forzani, one of the translators, and this is a hybrid talk. Some people are here, some people are in Zoom, some people speak in Spanish, some people will speak in English, and I will speak in Spanish. And then everybody can understand. I hope Gil can understand me too. I'm a professor here at the Facultad de Ingeniería Química, FIC, and I teach algebra, linear algebra, where I teach statistics to engineering, to mathematicians, and to very soon data science people. And I work on a statistic now in something that is called, it has a very grandiose name, that is sufficient dimension reduction. That is basically, you have data, and you want to use this data to say something about a target, okay? And the idea is to reduce this data. This is called dimension reduction. But the goal of sufficient dimensional reduction is to reduce in such a way that you have lower dimension, but still you have all the information you need for the target. And then it's very grandiose, and and the progress is not always, we cannot do too much progress because of that, but okay, I work on that area. And I would say that linear algebra, and specifically matrix decomposition, that Gil is going to talk about this today, and especially SPD, is like the heart of my work, let's say, in some way, or I need that a lot. And this is, and when I listened to the first talk of Gil in one of his lectures, he has a lecture about linear algebra for data science, I fall in love with his classes and his lectures, and I've seen almost everybody who listened his talk. But this story is going to be told by Pedro in Spanish, no? And maybe you can say something to Gil, but everything is in English.
So Gil, I'm going to speak in Spanish, so for our Spanish audience here. And
all good, yeah.
And I will tell a little bit about how we came up with translating this book. Bueno, con Liliana estábamos preparando la primera edición del curso de análisis matricial de licenciatura en matemática del nuevo plan, y nos tocó, estábamos preparando, empezando a ver cómo vamos a enseñar los temas, de dónde íbamos a sacar, y nos enteramos de la existencia de este libro y de los videos que tiene Strang en YouTube, preparados por la universidad. Entonces empezamos a mirar los videos, nos íbamos al mediodía a almorzar a lo de Lili, poníamos el video en la tele y mientras almorzábamos veíamos los videos y aprendíamos álgebra lineal. Me gustó tanto.
Es más, era más interesante que una serie de Netflix, ¿no? Nos perdíamos a nosotros para ir a ver.
Y nos teníamos prohibido que cada uno mirara solo.
Era bien Netflix, bien Netflix.
Y entonces, un día hubo un problema que Gilbert Strang hablaba de un problema y nosotros no lo encontramos en internet, y le escribimos un email para preguntarle dónde estaba ese problema para resolver, y él nos respondió sobre eso y nos ofreció traducir el libro. Nosotros no podíamos creer, nos daba mucho orgullo realmente ser invitados, era un honor para nosotros ser invitados a traducir un libro del profesor Gilbert Strang, a quien yo había conocido 20 años antes, a través de un libro suyo que tuve que enseñar, y me pareció maravillosa la forma que tiene de contar y de interpretar la matemática. I'm saying very beautiful things about you, Gil. I will tell you in English. I will send you an email. Y entonces, bueno, realmente estábamos fascinados, empezamos a traducir al día siguiente, nos dimos cuenta que era mucho trabajo, entonces la convocamos a Cecilia, que se había recibido hacía poquito de traductora literaria y científico-técnica de inglés, entonces ella nos dio una gran mano para poder avanzar y terminarlo mucho antes de lo que nos habría llevado. Así que realmente fue un honor. It's an honor for us to be the translators of this book. I admire you from all your books and some of your papers, and I had the pleasure of teaching a course on linear algebra based on your book, and I really got hooked into your way of presenting things.
Thank you so much.
You're welcome. Bueno, y ahora para presentar un poco la traducción del libro y al profesor Strang mejor, lo hemos invitado a Eduardo Sáenz de Cabezón, que es de la Universidad de La Rioja en España, que conduce un programa en la televisión española que se llama, de divulgación de ciencias, que se llama Órbita Laica, que tiene un canal de YouTube que se llama Derivando, que tiene 1.370.000 seguidores. Es un profesor de matemática que habla de videos de matemática y tiene 1.370.000 seguidores. La verdad que es una proeza. Bueno, tiene libros de divulgación de matemática, de premios. Es realmente otro gran honor tenerlo, Eduardo, acompañándonos en esta presentación.
Eduardo.
Bueno, muchísimas gracias. Muchísimas gracias. No sé muy bien cuál es la razón de que yo esté aquí, pero me parece maravilloso en todo caso compartirlo. Voy a decir unas breves palabras en inglés para saludar al profesor Strang y después paso de nuevo a castellano para decir unas breves palabras. Solo voy a robar 2 minutitos. So, as I was saying, I'm very pleased to be here. It's hard to say how pleased I am. Don't know exactly the reason why I am here, but I'm absolutely pleased to be. So for me, it was a discovery, the lectures of Professor Strang. I will say these very words later on in Spanish. It was a big pleasure, and it was quite a discovery, because there was a time in my career in mathematics when I, so to say, rediscovered the importance of linear algebra. Because when you're studying your degree, you study linear algebra as many other matters or some other lectures. But then later on, when you work in mathematics, you realize how important really is linear algebra, because it's in the foundation of almost everything. Now I'm working more in the interplay between commutative algebra and geometry, and linear algebra is all of it. Basically, it's just a bit more sophisticated, but it's all of it. And that happens almost anywhere you go in mathematics. So for me, it was a chance to rediscover linear algebra, and I wanted to learn more and learn linear algebra in a different way. And that's how I came across the wonderful courses Professor Strang gave at the MIT. And I was delighted to follow those courses, those lectures. I was really grateful for that. So it's a pleasure for me to say thanks to you in person, or sort of, for those courses. And I will just finish this very short words in English with a sentence that I heard in one of your courses. And that came to me like a motto when I teach linear algebra, or when I work, or when I speak about linear algebra to my students. And the sentence, the quote is as follows. Professor Strang, in one of his lectures, I believe is in elimination theory, he says, Gauss thought of it before us did, but only because he was born earlier. And it's very true. That's so very true. Well, he then continues, he also died earlier, and that's true also. So that's true. So it's a way to say some of the big mathematicians discovered or found the big ideas in mathematics, and after them, we see them only as natural things. And I think that's the biggest value of Professor Strang's way of teaching. He looks at very deep ideals and present them in a very natural way, so that you as a student really take part of this natural way of thinking about mathematics. So thank you very much, Professor Strang, for your lectures and for your book. I will just say this a little now in Spanish for the Spanish audience, speaking audience. Lo que estaba diciendo es que hace unos cuantos años, trabajando en matemáticas, redescubrí de alguna forma el álgebra lineal. No es que uno no comprendiera la importancia del álgebra lineal cuando la estudia, pero cuando uno se pone a trabajar en la matemática, digamos, teórica, ¿no? También en la aplicada, por supuesto. Yo creo que a nadie se le escapa las aplicaciones del álgebra lineal, pero en la matemática teórica uno de alguna forma se da cuenta de que todos los caminos conducen al álgebra lineal. Y está en la base de muchísimas de las cosas que hacemos, ¿no? Mi trabajo ahora mismo está en otro lugar, está, digamos, en la frontera entre la teoría de homología, la álgebra conmutativa y la geometría, y ahí todo realmente, las piezas básicas son álgebra lineal o generalizaciones de la álgebra lineal. Y entonces llegó un momento en mi carrera en que sentí el impulso, las ganas y el placer de volver a revisitar un poco las cuestiones básicas de la álgebra lineal. Y allí pues yo busqué varios libros, varias fuentes de información, y entre otras cosas me encontré con unos cursos que el profesor Strang dictaba en el MIT. Y para mí fue una delicia revisitar el álgebra lineal en esos cursos. No solo porque veías a una persona con una claridad expositiva sin parangón, era una claridad expositiva brillante, y que estaba solo igualada por la claridad de sus ideas. Él tenía unas ideas muy profundas y muy claras sobre esas cuestiones básicas en ese momento de álgebra lineal, pero expuestas de una manera brillante, muy clara y muy placentera de escuchar. Yo entiendo que sus estudiantes tienen mucha suerte, ¿no? Entonces encontré yo allí a un profesor pues, magnífico, una de esas ocasiones, como decía, en las que uno encuentra un profesor que es capaz de tener claridad.
Se le congeló a él, ¿eh?
Sí.
No a nosotros.
No, porque
una de esas ocasiones, y quiero agradecerlo también, en que la vida te da la ocasión de agradecer de alguna forma directa a alguien que ha hecho algo bueno de lo que tú te has beneficiado. Y terminaba con una frase, citando al profesor Strang, en una frase que él dice en uno de sus cursos, creo que es sobre teoría de eliminación, estoy casi seguro que es en la clase sobre teoría de eliminación, que él dice, Gauss ya pensó sobre esto mucho antes que nosotros, pero solamente porque es que él nació antes. Y me parece una forma muy buena. También dice que murió antes, eso también es verdad. Pero me parece una forma muy bonita de expresar que muchas de las ideas profundas que los grandes matemáticos nos dejaron tienen de alguna forma un origen muy natural. Son ideas muy naturales a las que nosotros también podemos llegar, y sobre todo si lo hacemos de la mano de un profesor como el profesor Strang. Así que muchísimas gracias por haberme dado la oportunidad de estar aquí y perdón por haber robado estos minutos de vuestro tiempo en una presentación tan bonita. Muchísimas gracias.
Muchas gracias a ti, Eduardo. La verdad que Bueno, ahora me siento un poco mejor de haberte... Sentíamos que te estábamos robando tiempo a ti al invitarte a dar esta charla, pero bueno, pedimos, por lo que dices, la posibilidad de dirigir unas palabras a Gilbert Strang, que admiramos tanto. Bueno, a continuación, el profesor Strang va a hablar unas palabras sobre algunos resultados de
que están en este libro. Que está
factorizaciones.
So now, Gil, it's your turn to...
No. Aquí tengo que ponerme los lentes.
Ese lo puedo cerrar.
Está bien, es chivo, está pasando todo el tiempo.
Aha.
Aha, now it's your turn to do your lecture that we are all looking forward. I will sit on the side so you can tell me when to move to the next slide.
Okay, thanks. So the most important thing I have to say is thank you. Thank you to Pedro and Liliana. It's just been a great pleasure to get email from you and to see your excellent translation evolving, just wonderful. And thank you, Eduardo, for those kind words. Would you like me to talk about mathematics just a little bit? Maybe the title, elimination, so that is what goes back to Gauss, and factorization is the fundamental way to understand important ideas in linear algebra. So let's go to the first slide and see what comes. Oh, okay. So here are 5 ways to factor a matrix. Typically, a matrix is just called A, and it's the first of those 5 that I want to speak about because that's not really well known. Let me just pause though and look at the other 4, which are very well known, which are the foundation of linear algebra. A equal L, lower triangular times upper triangular. That's the step that everybody takes to solve n equations in n unknowns, the basic problem. And then Q times R, that's involved with the names of Graham-Schmidt, who turn a set of independent vectors into orthogonal vectors. Orthogonal is really the wonderful property to have. And that's what makes the last 2 factorizations so important. So for a symmetric matrix, it's been known and used for hundreds of years that the eigenvectors of a symmetric matrix are orthogonal. Then you have a factorization of the matrix into this Q, orthogonal eigenvectors times lambda, the eigenvalues, times Q transpose. So that's the great spectral theorem of mathematics and quantum mechanics and everywhere. It's constantly used. But if the matrix is not symmetric, then the eigenvectors are not orthogonal. Well, it may not be orthogonal. And we want a factorization that allows every matrix, rectangular matrices also. Rectangular matrices don't even have eigenvalues and eigenvectors. Whoops, let me kill that telephone. Okay, so that brings us to the last one and the great one, the singular value decomposition. So here we have two sets of orthogonal vectors. With the symmetric case, we had one, the eigenvectors. Now we have left singular vectors and right singular vectors, inputs and outputs. And the matrix is almost surely rectangular. And that's where data comes. So it's the last one, the singular. I didn't put the letters SVD, but there they are. That's the great one that linear algebra builds up to. So please, everything I say today about factorization number one, the one at the top, that's the simplest. But I want to say a few words about A equals C times R. Okay, so let's go to the next slide. Now we concentrate on what is C and what is R. Okay, so we allow any matrix again, and its columns could be independent or they could be dependent. It could be some combinations of columns may give 0. So actually this factorization occurred to me as I was writing the first pages of the book you've just translated. In those very first pages, that was the first time I thought about this factorization of any matrix into, so the matrix has the matrix A has M rows and N columns, but those are probably not independent. So it's the number R that counts the independent columns and the independent rows, and it's the same R for columns and for rows. That's the first great theorem in linear algebra. And that's an amazing theorem. If you think of a matrix of size 60 times 100, it's got 60 rows, it's got 100 columns. So M is 60, N is 100. But how many of those rows and columns are independent? Well, it's a smaller number R, a smaller number R. And so this is like a really nice factorization. And it's in a way new, but of course it cannot be new, such a basic thing. It's the right way, I think, to look at elimination. So the elimination goes back to China thousands of years ago. And we all learn, every student of linear algebra learns about elimination. And I want to say, so we often teach about the row reduced echelon form, the result of elimination. But I like to say the result in this different way, as a factorization of C times R. So what is C? It contains the independent columns of the matrix. You start from the left and you keep every column if it is independent of the earlier ones. And then after a certain point, you have R independent columns, and then the rest of the columns are combinations of those first columns. So that's C. And then the matrix R is what is produced by this elimination process that we teach and we force students to learn. It is a basic, simple construction. It doesn't produce orthogonal vectors. Orthogonal vectors, those are more complicated. They come from eigenvalue problems, singular value problems. This is just independent, meaning that they go in different directions. No combination gives you 0. Okay, so there's the idea and my next slide will show what this matrix R is. Okay, yeah. Oh, all right. Here's the slide that explains A equals C times R. Can you follow the lines there with that? That's perfect. Yeah, those lines with any matrix A is C times R. So, okay, so what is C? C is the independent columns, the basis for the column space, set of R independent columns. And then what is the other factor, R? Well, it's a little more complicated, but it's exactly what comes out of elimination, comes out of doing what Gauss told us to do. So when you simplify the matrix, you get this identity matrix at the start, and then you get some other matrix F, which is whatever, that's really F that I want you to understand. So, and then that permutation P is not so important. It just puts the columns into the right order. It's really F is the interesting thing. Okay, so I have to say a little more about what F is, and then I'm complete. Okay, so when I do this multiplication, I have C, and which is the independent columns. Now, what is C times F? Those are the dependent columns. And what does dependent column mean? It means that those columns are combinations of the independent ones. That's why they're dependent. They depend on the C. They're combinations of the columns in C. And the matrix F, it just tells us what are those combinations? What combinations of the C, the perfect columns, the independent columns should we take? So that's it falls naturally, but again, what is the point here? Gauss proposed an algorithm which produces the identity matrix, and it produces this F matrix and so on. But seeing it as a factorization is one extra step that's very useful, it helps. So A equals CR, C and the R are not new, but putting them together is what I want to propose. Okay, just see if there's what the next slides tell us. Maybe it would be nice to have an example. Oh, this is the steps of elimination that end up by finding the identity matrix and the F matrix and the P matrix. I, F, and P, that's what we're going for. I won't dig into the details of this, of elimination. If you've suffered through a linear algebra course, you have met elimination. Oh, that reminds me, speaking of linear algebra, I'm really happy to say that there's now the new and the last edition of my main textbook. We have a picture of the cover, and I hope you like the cover design. Yeah. So this book is about 2 days old or 1 week old or something like that, the 6th edition. And it develops this A equals CR idea, as well as all the other more important ideas. And maybe everybody recognizes the cover there is a picture of what I called the 4 fundamental subspaces. So yeah, I won't. Anyway, just to say that I'm pleased about that, and I would be so pleased if someday it also has a Spanish translation, because it's like the end result. So I wrote when I was way back in the 20th century, I wrote a book called Linear Algebra and Its Applications. So that was a start of writing and teaching linear algebra at MIT. Linear algebra was a different subject then. It was all for pure mathematics. The applications, these factorizations were not part of the course. Anyway, that first book was a step forward, and then I started on this series, The Introduction to Linear Algebra. So forgive me for mentioning that this book, it arrived just about on my birthday, which was Sunday. So I'm still sort of celebrating the birthday with the family. Okay, so that's probably the last slide, and again, what's to say? I'm so grateful that linear algebra is better known, more appreciated, understood well. That's a great thing, and I'm so grateful for the initiative that Pedro and Liliana took to propose a translation, and I hope that working with SIAM, the International Applied Math Society, will be a success. Thank you again for inviting me today and for all the work of the translation. It's very, very much appreciated. Thank you.
I have two things for you, Gil.
Okay.
One of the things is, I was reading, this way to do product of two matrices, that you have your new way.
Yes.
And that when we learn eigenvector, we write like that. But then we never saw that like multiplication, like you do the first column with the first row plus
right.
Blah, blah. And we love that. I think it's when Pedro, Pedro is very like, when Pedro saw that for the first time in your book, I think it's the second page, he was so excited about that. We have to teach this.
Oh, well done.
And I like this, and I was reading all the editions of your books, Linear Algebra, and now I don't remember because I didn't prepare myself very well for today, but I suppose the first edition is which year? 83? No. The Linear Algebra book, one of the linear algebra book, 83 maybe?
Right. The other linear algebra book, which still exists.
But I was seeing all the editions that you have.
Yes.
And in the first edition, I think you don't talk about this way to multiply two matrices. In the second edition, you say only 3 ways, suppose. Yes. The second edition, you say 3 ways, and in a sentence, you said something about this way.
Is that right? Okay.
And in the second edition, it's like 4 ways to multiply. And then it was like, you got more excited and excited every edition.
That's true.
This is true because I was reading the...
Absolutely true, yes.
And I showed to Pedro that, look at this. You are not the only one excited. He changed his mind.
Yes.
This is the first thing. And the second thing about the CR decomposition that I want to say, when I first saw that, it was like a silly decomposition. Why is so important that?
Yes.
And then I realized, or maybe I read, I don't know, this is about that you have the true columns and the true rows.
Yes.
And this is so important because, well, in data science, people started using this because the column means what are the predictors that are important.
Right.
And then you have a way to select the predictors that are important when you do the approximation, okay?
Yeah.
And I saw even people in chemometrics, they don't say that it's a CR decomposition, but they use that because they have the same problem that they want to choose, but they use the row too because they want to choose what are the important predictors, let's say,
right,
and what are the important individuals too. Well, and you know that there is a CUR decomposition, etc. But at the beginning, when I saw that, I said, this this is a silly decomposition, no? And I see this one after, I fall in love with SPD for a while. Now that I more or less, I have an idea, let's say, now I think the CR is one of my favorites.
Thank you. Thank you. That's good. It's, you know, part of mathematics is, it's such a pleasure, right? You understand a little more, and then you use it, and then you understand a little bit more. It's we're all fortunate. Yeah. So,
is there any question?
Yes, any discussion. So,
una pregunta. Okay.
Yeah.
We really appreciate
the
chance first to translate the book. It's really an honor for us. And
then you got who was the editor of the book?
Yes, he also worked for us finding science to edit the book. And
yes.
We also appreciate your presence here today. Happy birthday.
Happy birthday.
Thank you. Yes, right. Well, it's I'm the one to thank you. Yeah, that's really good work. Yeah. So let's tell people about it the best way we can. Yeah.
Okay.
So I will show you for the audience again.
Yeah, please.
He's going to advertise now.
That's the important thing. Right. Yeah.
You can send the link through the Zoom.
Yeah.
Okay.
Right. So this picture was taken in Myanmar by my son. I'm sorry that people ask me, what does it have to do with the deep learning and data science? And it's only, I like the picture. It's a good answer. It's just anyway. I hope.
Is there any question from the Zoom people?
Yeah.
Okay, well, thanks.
Thank you very much, everybody. Eduardo also.
Yeah. Certainly, Eduardo. So I'll say goodbye and thank you.
No queremos. Chao, Eduardo.
Muchas gracias.
Muchas gracias.
Gracias, está muy bien.
Nos vemos.
Muy bonito.